question number 5. So in this case I will choose green pen. So I have question number 5. So in the question number 5 I have this current carrying conductor which is 3 ampere, and the distance here is 5 ampere, and at this point P, this is 20 centimeter, and this is also 20 centimeter. Yep, I am back here. So sorry for the delay. So yeah, I have this conductor, and there are two wires in the figure given below. So one is this 3 ampere, and the other one is 5 ampere, and these are basically coming out from the plane of paper. So we'll draw a circle here, and we can clearly, like, there is a right hand thumb rule. So whenever we want to um, calculate, or whenever we want to predict the direction of magnetic field of a current carrying conductor, what we'll do is that, so basically we use the right hand in this case, and so basically the current is coming out from the plane of paper. So I'll just keep my hand like this, and I'll just curl it. So this curl will give me the direction of magnetic field. So it is basically going to be in the anti-clockwise direction. And we need to first, for the first part, we need to calculate the magnetic field in the between, and for the second we need to calculate the magnetic field at this point P. So for the A part, I'll just go along with the solution also. So for calculating the magnetic field of a current carrying conductor, we have the formula. So B here is the magnetic field, which is mu naught I over 2 pi r, and I is the current, mu naught is the permeability of free space, which is 4 pi into 10 power minus, it is 7, I think. I'll just cross check this value. Yeah, so 10 power minus 7, and this is 2 pi. And but if we have two conductors, so for that we'll calculate this by mu naught I2 over 2 pi. Now R will be, let's say A, where A is going to be 10 centimeter, because we are going to calculate at this midpoint, and this distance is going to be 10 centimeter, minus mu naught I1 over 2 pi, and again this distance is going to be A, because it will be so, and my I2 will be 5 ampere here, I1 will be 3 amps. So I can just plug in these values, and after that I'm getting, so this 5 minus 3 will be 2 times pi times 4, and then it will be divided by 2 times pi times 10 centimeter will be 0.1 meter, and this will be into 10 power plus 7. So this will be 10 power plus 7 mu naught is in the, okay, it is in the numerator part. So 40 into 10 power minus 7 will be 4 into 10 power minus 6 Tesla. So this is going to be the magnetic field at this point. For B part, for B part we need, I'll just use the vector diagram also given here. So I'll just again draw this. So this is point number 1, this is point number 2, this will be point number 2, and this will be my D distance, so this will be point number P. Now for calculating magnetic field at point P due to 1, I will use this distance, and for this one I will use this distance. So this will be 20 plus 20. So basically this is a right angle triangle, so I'll just use the Pythagoras theorem. So this will be 20 square plus 20 square, it will be 20 root 2 centimeter due to B1 or due to 1. Mu B will be mu naught, and this will be I is 3, mu naught I over 4 to pi, and distance will be 20 root 2. So this will be 3 into 4 into pi, and pi can get cancelled, 4 will cancel with 2, so this will be 6 over 20 root 2, and this will be 2.212, 0.212 into 10 power minus 7 Tesla. I'll just cross check with yeah. So now in this case we can see that clearly we can see that the magnetic field at this point will have two components. One will be in Y, which will be B1 B1Y, and one will be in X. This will be B1X, and this is basically the vector B1, and this is going to be the angle, and this angle is going to be 45 degrees. So I can calculate, and yeah, for the magnetic field due to this second wire, this magnetic field is going to be in, so it is in anti-clockwise direction, so this will only come for this, what we say, X direction. So in the X direction we will have B2 also. So I'll just take the components here. So B1 sine theta will be B1x basically, and this will be into sine of 45, so this will be 0.15 into 10 power minus 7 Tesla, and B1 cos theta is going to be the same because it is the trigonometric ratio for 45 degree. So this will be B1y. Oh, this was B1y, this is B1x. This is B1y, this is B1x. 0.15 times 10 power minus 7 Tesla. And for the magnetic field due to this second wire, we have B2, which will be in X direction. So this will be again mu naught 5 over 2 pi, and this will be 20 only. So this will be 10 over 20. So 10 over 20 will be 0.5 into 10 power minus 7 Tesla. I'll just make sure that these values are correct. So I am skipping a negative sign here, and that is true. It should be negative. Yeah, so yeah, no problem. So basically we can see from the diagram that these fields are in negative X direction. So I'll just put a minus sign here, and I'll just put a minus sign here. Now to calculate total field for at point P, we'll just sum up the components of X and Y. So I'll just, and we'll take the magnitude of that vector, or we'll just sum the vector in as a whole vector. So in this case, what we'll do, so this will be, so for Bx total, this will be minus of B1x plus B2. So this will be 0.15 plus 0.5 into 10 power minus 7, and this will be 0.65 what is wrong with this Outlook? This is not good. This is absolutely not good. I don't appreciate such kind of things. Seriously. Oh, yeah, so it was minus of 0.65. This was 10 power minus 7, and by will be the same. So by was 0.15 into 10 power minus 7, and we'll just take the magnitude. So this will be 0.65 whole square plus 0.15 into 10 power minus 7, and this will again be whole square. So I'll just take the 10 power minus 7 outside, and I'll just square this. So 0.65 square plus 0.15 square and square root of answer. So this will be 0.667 into 10 power minus 7 Tesla. So let's just cross check with the solution. I have done some mistakes. So basically, first mistake I have done that I haven't taken the distance in meters. So I took the distance in centimeters. I think that our answer can be wrong in this case. So the answer is, yeah, I'm not sure that why it is coming correct, because I took, okay, sorry. So basically here also I took, no, I don't think so. But the solution given by Junior Tutor is also pretty much the same. So I'll just If I take, yeah, so yeah, so clearly we can see here that I am having this one decimal problem. So there they are getting the decimal as 10 power minus 6. So it is nothing, basically I just needed to multiply this with 10 power minus 2, and it will go upwards and it will become 10 power plus 2. That will become 10 power minus 5. So I can correct it here only. So this is the wrong answer. So this will be 10 power 667, 0.67 minus 10 power 5 Tesla. And if I take one more, I take this here, then it will become 10 power minus 6. Yeah, so I don't suggest you guys to do such kind of things, because it is good, or it works for those people who have like a good command on such kind of questions or some kind of experience. Solution is correct. Good work.